Hi everyone. Are you able to hear me?
Yes, sir.
Okay.
Yes, sir.
So let us start this week's practice problems, and these will help you in solving assignment 4 this week. So these are some previous year's questions. So the values may be different. Please be careful while you're solving uh, your assignments. Do not use the same values as I have used in these questions. Okay. So let's start. Okay. So in this question, uh, we have this circuit here. This is a PMOS, right? Because you can see arrows like this. It is a PMOS, and we are given the bias current, DC current, is 124 microamperes, and K value is given. This is the saturation equation. VT is zero point 0.5 volts. We have to find the values of R1, R2, RS, and RD. Uh, Approximate gain is also given since AC is applied here, so we will have to find gain also. And for the first part, we have to just find the value of RS. Okay, so let us try to solve this first. So before trying to, okay, 1 second. So before moving ahead, let's first try to find the gain of the circuit. What is V out by V in? So for that, and it is given as -5 already to us. So for that, we will use the universal equation or that we can get from the small signal model. I have already told you in a few of the previous classes. So it is ID equals to GM VSG plus GD VSD, right? Uh, so if someone is not sure from where does this equation come from, so if we draw the small signal model of PMOS, right? So from this equation, ID equals to GM VSG plus GD VSD. This is VSD. So from here, this equation comes to use, and we will use this extensively to solve all of the questions related to gain. Okay. So anyways, so let's move ahead. So ID. So here, okay. So what we
Sir,
will do is, yes,
sir, is it 1 by GD or GD?
it is 1 by GD. So uh,
Okay.
yeah.
So the equation should change, I guess.
No, this resistance is 1 by GD. So current is, so what I'm doing is telling is this is KCL, right? ID equals to this current plus this current. So
Yes.
GM VSG is one current plus other current is, this is the resistance. 1 by GD is the resistance. So voltage upon resistance is the current. So it becomes GM VSG plus GD, sorry, VSD. Is it clear? Or you
Yes,
want
sir.
me to
Thank you,
repeat?
sir.
Okay.
No, sir.
So anyways, so for most practical values, GM is much greater than GD. So we will ignore this part of the equation just for timing to find a simplified gain formula. So anyways, so now we get ID equals to GM VSG. Okay. Now here, okay. So this is the source terminal, right? And this is the drain terminal. So the voltage at source will be, if I put Vs equals to minus ID Rs, right? The voltage here, AC voltage here. So please stop me whenever you feel like there is any, if something is not clear. Okay. And Vg is V in. So let me clarify again. I am doing this small signal analysis. So that is why I'm ignoring this 5 volts and everything else. And this ID is the AC current, not the DC, because we are finding the AC gain. This ID is also AC. These voltages are also AC voltages, not DC. Okay. So we had uh, ID equals to GM VSG is one equation, and we have Vs equal to minus ID Rs, and Vg equals to V in. Okay. So okay. Now if we see at this terminal, what is V out voltage? V out will be ID RD, right? Okay. V out equals to ID RD. So ID equals to V out by RD. Now we will put this value in this equation here ID, and we will put this Vs and Vg values also. So we will get V out by RD equals to Gm times Vs is this minus ID Rs, and Vg is Vn minus Vn. Okay, so sorry. So V out by RD equals to, okay, let me take common, minus equals to Gm minus I. Okay, I'll replace ID here also. V out by RD Rs minus V in is V out by RD. Now I'll take V out by RD common this side. 1 plus Gm Rs equals to minus Gm V in. So V out by V in equals to minus Gm by 1 plus Gm Rs RD above. Yeah. Again, Rs will be in kilo ohms and this will be also in millisiemens. So Gm Rs would be greater than 8 and 1. So we can ignore this one. So we get V out by V in equals to minus RD by Rs. This is the gain. Next, once we have found the gain, now our original task is to find this value of Rs. Okay. So now I've found the gain. Okay, so here, uh, so I know this DC current here. So let us try to put case KVL here. Okay. So 5 minus ID Rs. Now this is I'm solving for DC, right? So So I'm using this 5 because I have to find this resistance value. Minus VSB minus ID RD equals to 0. So VSD equals to 5 minus ID RS plus RD. Okay. So now our ID has two components, ID equal to ID plus ID. So this is DC, this is AC. So, okay. So if I expand this, ID equals to K VSG minus VT equals to K Vs minus VG minus VT equals to K, and that is Vs minus VG is first, okay, small VG is VG minus V in minus VT. So voltage here would be what? The DC voltage here VG plus this AC voltage V in. So VG, total VG equals to V DC plus AC. This I have written here. I have expanded this as this. So now what will happen is to our total current. So when this V in increases, we can see this ID will decrease, right? So V in increases, ID, okay, not this ID decreases. So the so since this ID is the sum of both DC and AC currents, so the total current cannot be zero through this circuit, right? If it is giving some gain. So the minimum value of ID for maximum value of V in will be 0. So what I'm saying is when V in is maximum, ID is minimum and it is equal to 0 because it cannot go below 0. So we are taking the worst case. So what this means is ID equals to DC plus AC. So to make this total current 0, this ID should become minus ID, right? So small ID will become I minus ID here in this case for minimum. That's why ID equals to 0. Now in the maximum case, when V in is minimum, ID will be maximum. So ID, so since, okay, let me show. So this is the AC, right? So it will be something like this. So if this minimum value is minus ID, its positive value will be plus ID. So the maximum ID will be ID plus ID, and in this case it will be positive. So total current will be 2 ID in the when V in is minimum. Okay, so okay, fine. Okay. So now what was our VSD equation? VSD equals to 5 minus ID RS plus RD equals to 5 minus, we will take 2 ID RS plus and again, okay. Our V out by V in gain was minus 5 equals to RD minus RD by RS. Therefore, RD equals to 5 RS. So I'll write RS plus 5 RS DSD. So, okay. Now ID equals to K VSG minus VT whole square. So VSG minus VT equals to under root ID by K, and we know VSD should be greater than equal to VSG minus VT for PMOS saturation. So VSD should be greater than equal to under root ID by K. So we will take this worst case and let's take it under root ID by K, and ID we found to be 2ID. 5 minus 2ID RS plus 5 RS. Now if I put ID equal to 124 microampere and K equal to 3.83 millisiemens per volt, I will get RS equal to 3.1892 kilo ohms. Uh, so yeah, this is the answer for this part. Is there any doubt in any part of this question?
No, sir.
Okay. So in this way, just by changing some values, you can solve the question given in your assignment also. Okay. So now the part is what is the value of RD? Okay. So we already know V out by V in equals to minus 5 equals to minus RD by RS. We solve this. So RD equals to 5 RS. RD equals to 5 times. Our answer is 3.189. 3.189 kilo ohm. So it will be 15.946 kilo ohm. So this is easy once you have found the gain, so we can directly find RD. So I hope there is no doubt in this part. So let's move ahead. Okay. Now we have to find the value of R1. So yeah. So this is R1 and this is R2. So to find that, we know we have this DC current and this DC current. So this 0.5 microampere is flowing through this branch, and this 124 microampere is flowing here. So let us first find the voltage here, Vs, because we will need it for in the current equation. So let us find this Vs. So Vs equals to 5 minus IDRs, and it is 5 minus ID, we know 124, I think. Yeah. ID is 124 microamperes. So 124 micro into RS, we just found out it was 3.189. Okay, so Vs we will get as 4.604 volts. Now this ID is K VSG minus VT whole square. So VSG minus VT equals to under root ID by K, or Vs minus Vg minus Vt equals to under root ID by K. So we know Vs, we just want to find Vg. So Vg will be Vs minus under root ID by K minus Vt. So VVG we will get as 3.92 volts. So we have found the DC voltage here. Now, okay, we know voltage here, we know voltage here, we know current, so we can find R1. So R1 will be 5 minus Vg by 0.5 microampere. 5 minus 3.92 divided by 0.5 means it will be 2.16 mega ohms. So So let us find R2 also here because it will be asked in next question. So R2 will be Vg minus 0 divided by 0.5 mu. R2 equal to Vg minus 0 by 0.5 mu. 3.92 by 0.5 mu. So R2 will be 7.84 mega ohms. So this is R1 and this is R2. Okay. Any doubts in this part?
Sir, it is clear, sir.
Okay.
Sir, try to focus more on the last two problems, sir, 10 and 11.
Okay.
Please see that those two are also covered today.
Sure. Okay. So let us solve a easier one first. Let us skip all these. 6, 9. Okay. Let me first solve 9, then I'll solve 10. Okay.
Okay.
Because these are very similar problems. All are. Okay. So let me get some of this. So this is the circuit that we have been given. So all three are PMOS, right? So let us take this current as I1, this as I2, this as I3. So we know I1 will be equal to I2 equal to I3, but let us just for writing the small signal equations, let us consider them separately. So I'll write equation for I1 equal to, so like I have told, ID equals to GMV VSG for PMOS plus GD VSD. Now we will also take another component GMB is given, which is body, the conductance due to body VSB. So this is the equation. So we will use this equation for all three transistors to solve the for gain. So for I1, GM1, what is VSG? So here this is source, this is drain, source drain, source drain. So VS is V out minus gate is in V in plus GD, VS is V out, VD is 0 plus GMB. It will be Vs equal to V out and body will be at VDD, so obviously it will be ground. GMB V out. Okay. So any doubt in this equation?
No, sir.
Okay. So now I'll write for I2 quickly. I2 will be GM2. Okay. So let us take voltage here to be, let's say, X or Vx, right? At this point, because we will need this node voltage also. So I2 is GM2 and VSG. Vs is Vx and gate is grounded. So Vx plus GD VSD. VSD is Vx minus V out plus GMB. Okay, it was 1 1. So I'll write it as 2. GD2, GMB2, GMB2 Vx. I3 will be GM3 and Vs and Vg both are ground, so 0 plus GD2 VSD. Vs is 0 minus Vx plus GMB 2, sorry, 3, that's 3, GMB3, and it is source is grounded and body will is VDD, so it is also 0. So we have these three set of equations, so we will use them to solve V out by V in. So first of all, let us try to find a relation between Vx and V out, because we want to eliminate Vx, right? At the end we only want the result to be in between V out and V in. So to eliminate that, let us first take I2 equals to I3. So I'll just take Vx common, Gm2 plus Gd2 plus Gmb2. Okay, and at this side also we have this. So when I take it to the left hand side, this minus will become plus. So I will have plus Gd3. Okay, so equals to, only the component left is this Gd2 V out. So equals to Gd2 V out. So Vx equals to Gd2 V out by Gm2 plus Gd2 plus Gmb2 plus Gd3. So let us take Vx equals to kV out, because it is too hectic to write this again and again. I have taken this value as k. Okay. So next, to solve, we will take these two equations, I1 and I3. So now we know what is Vx in terms of V out. So we will get a relation between V out and V in, right? So let us take I1 equals to I3. Let me copy I1. And I3 was GD3 minus Vx GD3. Okay. So now let me write it. GM1 V out plus, okay, minus GM1 V in plus GD1 V out plus GMB1 V out equals to minus Vx. Okay, Vx I'll write KV out. KV out GD3. So let's take V out common. GM1 plus GD1 plus GMB1 plus K GD3 equals to GM1 V in. Now simply we can write V out by V in as GM1 by GM1 plus GD1 plus GMB1 plus GD3 into some K value, right? What is K? GD2 divided by GM2 plus GD2 plus GMB2 plus GD3. Okay. So now we can directly solve this. All these values are given. So GM1 is given to be 1.6 millisiemen. GM2 is 1.8 milli. GM3 is 2 milli. GMB1 is GMB2. GMB3. GMB1 is 0.32, 0.6, 0.67. GD1 is given as 1 by RD1. It will be 0.04847. GD2 is 1 by RD2, 0.4185. I'm writing it in millisiemens. Everything is milli. So we can just substitute directly. 0.055 millisiemens. Okay. So now if I put all these values, I will get answer V out by V in is 0.812. So for your questions, only these values are different, but this won't change. So if you put your own values, you can get the answer um, for your assignment. So this derivation won't change. Only these values you have to play with. So is this question clear?
Yes, sir.
So similarly, I'll solve 10 also. So it is very similar. We will write 4 equations for all 4 transistors and then try to eliminate whatever we can and find a relation between V out and V in. So let me write this. So here is the circuit. So I've taken this as Vy and this as Vx. And these two are PMOS, these two are NMOS. This circuit is also cascaded. Sorry, not cascade, it is cascode. Yeah. Yeah, it is cascode. So why cascoding is done is like what cascoding means is we have added 2 transistors in series. So what it does is it increases the impedance here. So what gain is what? Gain is GM Z out, right? So by adding these 2 transistors in series, we increase Z out increases. It increases by a lot amount. Anyway, so let us find out the gain. Again, we have 4 currents, so I'll write I1 equals to GM1 V in plus GD1 PX plus GMB 0. Our source is ground, so GMB is 0. I2 is GM2 minus Vx plus GD2 V out minus Vx plus GMB2 Vx. Sorry, minus Vx. So, okay. So for NMOS, let me write here. For NMOS, ID equals to GM VGS plus GD VDS plus GMB VBS. For PMOS, ID is GM VSG plus GD VSD plus GMB VSB. So that is why I have taken it is for NMOS. That is why I have taken it negative Vs, because it will be VB minus Vs for NMOS, and VB will be ground and Vs is Vx. So that is why it is minus Vx. So I3 is GM3 Vy. So now it is PMOS. So it will be VSG. This is source, this is gate. So VSG is Vy plus GD3 Vy minus V out plus GMB3 Vy. I4 is GM4 into 0. This is ground because this is VDD and AC ground. This is also ground. So it is 0 plus GD4 minus Vy plus GMB 0. Okay. So next, what we will do is we will try to eliminate Vy first. So for that, we will equate these two equations. So I3 equals to I4. Now I will directly take Vy common. GM3 plus GD3 plus GMB3 plus GD4 equals to minus plus GD3 V out. Okay. So Vy equals to GD3 by GM3 plus GD3 plus GMB3 plus GD4 V out. And I'll take this value as K. So Vy equals to K V out. Okay. So now what we can do is we can try to eliminate Vx. So for eliminating, so now we know Vy in terms of Vx, right? So we can use these two equations to eliminate Vx. So let me copy these equations. Copy I2. So I'll do I2 equal to I4. I4 equals to minus GD4 Vy. Okay. So yeah. So now I'll take minus Vx as common. GM2 plus GD2 plus GMB2. So we've taken this, and this. This we will take plus GD4 equals to minus GD2 V out. So Vx equals to, okay, sorry, I made a mistake somewhere. This is an incorrect equation. Let me write it again clearly. GM2 minus Vx plus GD2 V out minus GD2 Vx minus GMB2 Vx equals to minus GD4. We will write it as KV out. Okay. So Vx minus Vx GM2 plus GD2 plus GMB2 equals to minus V out KGD4 plus GD2. Yeah. So Vx equals to V out KGD4 plus GD2 whole upon GM2 plus GD2 plus GMB2. Now let us take this as another variable because it is too big. Let us take it as C. So Vx equals to CV out. So now uh, we know Vx in terms of V out also. So we will equate these two equations to find V in versus V out relation. Add a page and copy this equation. I4 is minus GD4 Vy. It is minus GD4 KV out. Okay, so I'll do I1 equals to I4. GM1 V in plus GD1 Vx equals to minus GD4 KV out. So GM1 V in plus GD1 CV out. Vx equals to CV out minus GD4 K V out. So let me take V out common. V out GM1 V in equals to minus V out K GD4 plus C GD1. Yeah. So V out by V in equals to minus GM1 by KGD4 plus CGD1, where K is GD3 by GM3 plus GD3 plus GMB3 plus GD4, and C is GD2 plus KGD4 by GM2 plus GD2 plus GMB2. Okay, so in this question, in the previous assignment, they did not give value of GM4, GD4, and GMB4. So I cannot solve the numerical value, but you can use these three equations to find the answer in your case. In your assignment, these values are given. Is it given? Let me check. Yeah, in your assignment, these values are all given. So, any doubts here?
No, sir. No, sir. The procedure is clear and we can do.
Okay. So, I have not included question 11, but it is very similar. So, here, I think in question 11, what they have done. In question 11, they just add another register here, right? And everything else is almost same. You just, for every such type of questions, you have to just use these two equations
Okay.
and the question will be easily solved. So let me do one where there is register. Okay.
So we have to calculate small signal gain for with respect to
Sorry,
resistor, right, sir?
sorry.
So we have to calculate again
Yeah, yeah,
calculate the small
yeah.
signal equivalent
Yes,
with
yes.
respect to resistor.
So I
Okay.
uh, let me solve this question. So it has register also. So I'll solve this one for reference. So it is easier for you to solve the 11th question. Question 6. So for solving this also, I'll use the same equation. So these both are NMOS only. So let me just erase this. Okay. So let us take it as I1, I2. Okay. So I1 is GM1 VGS. So VGS is V in minus V out plus GD1 VDS. VDS is minus V out plus GMB1 VBS. VBS is minus V out. Okay. And I2 is GM2 VGS. VGS is 0, it is short, plus GD2 VDS. I've taken it as X again, this point, VD2 VX plus GMB 0, because source is grounded and body will also be grounded. So these are the two equations. So again, now the thing that is different here is we will get an equation in terms of resistor also. So if we just apply KVL here, so Vx equals to V out minus I2R, right? So is this correct? Yeah. I2 will flow here, or you can take I1 also, it doesn't matter. So I have taken I2 because it has only one term and it is easier instead of I1 having three terms. So yeah. So Vx equals to V out. I2 is GD2 Vx R. So I'll take Vx common, Vx 1 plus GD2 R equals to V out. So Vx equals to V out by 1 plus GD2 R. Yeah. Now I will substitute this value of Vx here in this equation. Okay, so let us first again take it as kV out, so it is easier to write. So now we'll equate these two. So GM1, okay, let me write it like this. Take V out common directly. V out, uh, okay, let me just write completely. Use this 0. And I did Vx as kV out. V out. Okay. So GM1 V in minus GM1 V out plus GD1, sorry, minus GD1 V out minus GMB1 V out equals to GD2 K V out. Let's take V out common. GM1 V in equals to V out KGD2 plus GM1 plus GD1 plus GMB1. So V out by V in equals to GM1 by GM1 plus GD1 plus GMB1 plus KGD2. Okay, I'll replace K with its value. K is 1 by 1 plus GD2R. So here also all the values are given. GD1 is GM1 is 1.6 milli and GM2 we don't need. GD1 0.04847 milli. GD2 is 0.04185 milli. GMB1 is 0.32 and GMB2 0.6 milli. So when I substitute, and R is also given here. R is 4.6 kilo ohm. So if I substitute all these values, I'll get V out by V in as 0.7985. This. So in this way, when a resistor is given, you just have to write an extra equation and you will be able to solve that also. Any doubts here?
Sir, can you show that page which are written the final equation?
Yes. Again, same equation will be used for you. Only these values will change, which should be given in the question.
Sir,
Okay,
I
sir.
But
want to ask a question.
yes,
Like, can you show the diagram,
yeah,
circuit diagram?
this or okay, this is
Yes,
yeah.
this one. This. Sir, can we do one thing? Can we draw the equivalent resistance of M2 and then keep then add this to R and use the common drain formula?
Yes, you can. Yeah,
Can we do this thing in question number 9 and 10 also?
Yeah, but it becomes okay. Yeah, you can do that. It's not a problem. You can solve anyway. Question number 9. So here I will have to find the resistance here also, here also, here also, here. So how I think Sir has solved is he has found the resistances and the short circuit transconductance. Then uh, he has taken gain as uh, GM into Z out. So at this node, he has found impedance here, and then just multiplied it by GM. So that way you can also do, but here we do not have to worry about anything if we use this method. We just need these two equations and we just have to solve these all the equations and eliminate the variables. So in this way, like there, your answer will never be wrong.
Sir, I have one doubt, sir,
Yes.
regarding the direction of the short circuit current IN we need to consider. So can you explain that, sir?
Which short circuit current?
No, when we solve the problem is Norton's equivalent. In that case, we will show the short circuit current by IN, right? In that case,
Uh,
suppose if I show the direction of IN towards ground, then what should be the direction in the final equivalent circuit? It should be from the ground to the circuit or from the circuit towards the ground.
okay, let me see. I'll have to see what Sir has drawn, and just give me a moment. So, okay, so I found some example from the video. I think it is in week 3, first video. So I think they're trying to solve the common drain amplifier. So what they have done is, if I have this, and there was here it was RS parallel with RL. So Sir has taken Norton equivalent for this. So
Yes,
the
yes,
Norton equivalent will be, so for Norton equivalent we always have this kind of circuit, right? And then
yes, yes.
here we connect the load RS parallel with RL. So if this is IN and this is RN. So so what it will be? So the direction will be like this only because the IN will be coming. Because if I draw this, IN will be going like this, so it will be entering here. So the direction would be like this for IN. Uh, was this your question?
Yes, sir. Yes. Yes.
Yeah. So anything else? Any other doubt in any of the questions that I've solved today?
So can you solve question number 8?
Question 8. Let me see. Okay, I am not here. I will see. What is question 8? Question 8 is here this. Okay. So again, we will do the same thing. We will let me copy those two equations here. So I prefer this method, but you can take any method. I find it easier because we just have to worry for these two equations. In any other method, we have to like take care of many other things. Okay. So let us first write equation for m1, uh, I1. No, it will be I2. Sorry, I2, I1, I3. So I2 will be. Let us take it as Vx again because we need some value here. GM2 VGS. VG is Vx. Yes. GD2 VDS is also Vx plus GMV is 0. Vs is 0. I1 is GM1 V in minus Vx plus GD1 V out minus Vx plus GMV Vx. I3 is, let us take it as Vy. I3 is GM3 minus V. Okay, no need. Vy. GM3 minus V out plus GD3 minus Vy plus GMD 0. Yeah. So now let us find a relation between R and this. So V out equals to Vy minus I3R. So so now I can just substitute I3 from here and find the relationship between V out and Vy. So I think the rest you can do, right? We have already solved many like this. Yes, these equations are important. Rest you can solve them. Is there any doubt here, or do you want me to do it completely?
No, sir, we can do. We can do, sir.
Okay. Okay. So any other doubt, or we can close the session if there is no other doubt.
So in
Sir,
question number
in
one,
first question,
Sorry.
in question number one, sir, that's the problem. What is it? When we calculate for ID maximum, how can we calculate that question?
Okay.
yes, sir,
We
One
have
minute.
same doubt.
ID maximum.
Okay. Okay. 1 minute. 1 minute. Okay. This question, right? Yeah. Here. So what is the doubt here?
How we said I
Okay.
small I
These
capital I
these
D.
values.
Yeah, exactly.
Okay. Let me try again. So let us just take this equation, right? So is this equation clear? What I have written here?
Yes, sir. Yes,
Okay.
yes,
So let
clear.
I just take this equation, then we will see. So what we are doing is we have this MOSFET, let's say. We are applying an AC voltage here, and let's say an AC current ID is flowing. So if Vn is this AC current, some for this Vn, some ID is flowing, AC ID, which is also, which will, if it is sinusoidal, it will also be sine, right? But phase may be different. So that we will see. So from here directly we can see that it is Vn has this minus term. So if I increase Vn, ID will decrease, right? So for maximum Vn. So let us take this value of Vn. For this maximum Vn, so this ID is actually this ID is net ID. It is AC plus DC. Let me write it. ID equals to DC plus AC ID. So this total ID through the circuit will not be zero, right? Else the circuit will stop working. We do not want that. So we take the edge case when this ID becomes zero. It will become zero when this ID becomes minus ID. So this ID becomes minus, when Vn is maximum, this ID becomes minus ID. That is why we get this total current to be zero. So we really do not need this calculating this maximum or minimum case, but why are we doing this? Because we have to find RS, right? So this is the equation. I cannot take the minimum case because ID is zero. I cannot find RS and RD. That is why I go to this second case when ID is maximum. So, right, okay, for the maximum case. So for maximum case, Vn must be minimum. So Vn, when Vn has its minimum value, so since it is a sine wave, if it is its negative value is minus ID, its positive value will be plus ID. So that is why I taken this for the when Vn is max minimum, ID is max, ID is ID plus small ID, and small ID is again ID. So ID equals to 2ID. Does this make any sense now?
Yes, sir. Okay.
Anything else? Okay. So if not, we will close this session today, and I will upload the recording and the lecture notes in the link, in the drive link and the YouTube channel that we have. Okay. Thank you all.
Thank you, sir.
Thank you, sir.
So any research paper we have to take?
Sorry.
Any research paper we have to